Good day to you all, and welcome to this Motec webinar. My name is Dwayne Mitchell, and I work at the Motec Research and Development Centre in Melbourne, Australia. The title of today's webinar is How to Set Up Custom Datasets in ECUs and Dash Loggers. So the topics we're going to cover today are firstly how M800 and Dash Loggers coordinate with each other and exchange data. Secondly, we'll look at our standard data formats. And thirdly, how we can set up custom data formats and save these in the form of templates. Then we'll go through a step-by-step process of how we send M800 data to a Dash Logger, and then finally we'll cover how to send Dash Logger data to an M800. So it's a pretty straightforward webinar, and effectively we'll be showing each of the screens that you should be seeing on your PC software to assist you in setting up these options. So we have a complicated range of possibilities to move data between our different devices, and typically people will be using our M800 ECUs or our 100 series ECU family and one or other of our Dash Loggers, which would be ADL, the ADL2, the ADL3, the SDL3. Now we have two normal forms of data interchange between these devices. The earlier form of data exchange is serial, or RS232, where we have a separate transmit and receive line. And then we also have CAN, which is Controller Area Network. Now RS232 data is an older system which has been in use for many years, is a reasonably good system at a lower speed, whereas CAN is a newer standard that's been around for about the last 25 years, has much higher data rates, a great deal more flexibility, and also a lot more data integrity. By that what we mean is that the data is checked and protected, so that if there's any issue with the values that are transmitted, the CAN system can recover that information. RS23 systems tend to send data without any form of error checking, and so Motec has incorporated some error checking into the way this data is transmitted and received. Most of our Motec devices will use either of these communication methods. However, CAN is generally our preferred option, and in fact some of our newer devices are CAN only. So in terms of this webinar, we're going to concentrate mainly on how we would use CAN, but I would suggest that you can do a lot of the same thing using the RS232 systems, and in fact our ECUs and dashes have more or less identical setup for each of these options. So to simplify moving our data around, Motec has already created a set of standard data formats, and this allows us to more or less plug and play, whereas we can just select one of the standard data formats in both devices, and then the transmitting and receiving is more or less synchronized, and the data will appear in the same form in both devices. Now our data formats cover quite a lot of the standard data that's used between M100 series ECUs and dashes, and in that case it's quite possible that you can use one of our standard data formats without the need to set up a custom data set. So although this webinar is about how to use a custom data set, it's worth noting that many of our standard data formats will actually resolve the data transmission needs that you have. There are some limitations on our standard data sets, and that's why it's necessary sometimes to use custom data sets. There are, for example, the user channels in an M800, of which there are 8. 4 of them are transmitted as a matter of course in our standard data sets, but the last 4 channels are not. The other difference is that standard data formats tend to use quite a lot of data, transmit a fair bit of data on the bus, and it's not necessarily the data that you're interested in, and it's not necessarily in a format that you may need. So this is why we do have the custom data formats, so that you can tailor the transmission and reception of the data to suit exactly what it is that you're doing. Now here's just an example of the standard data formats out of an M800, and what we're seeing here is there are 3 standard data sets that the M800 can transmit, and of those you can see that data set 1 actually includes a vast amount of standard data from the M800. There are a number of other data sets which have a slightly reduced number of channels, or alternatively use a slightly different transmission method. So you'll see that dataset 2 does not include some of the channels in dataset 1, and dataset 3 is almost identical to dataset 1, but it uses a slightly different transmission mechanism. But in many cases, using dataset 1 is a very simple option, and you can see all of the channels listed on this table are available as a matter of course. One of the reasons we have numerous datasets is, for example, dataset 3 is quite often used in our MDD displays, and this allows you to just transmit standard data straight to our miniature dash without any need for setup whatsoever. So this is very similar to our dataset 1, but it has a few minor differences. Again, you can see that user channels 1 to 4, which I'll just highlight now, these channels here are already transmitted as a part of our normal data set. So if you have, for example, some particular input into one of those channels, you'll already have it transmitted on these data sets. Okay, so the point here is that if you're not including the data you need in these standard data sets, you may have some unique need. Typically, this would include the use of AT inputs on an M800 as a switch channel. There are no transmitted switch channels in the standard data sets, and so it's quite handy in this case to use a user channel and a custom data format. Now in the M800 we can actually create two different custom data sets, and either of these can be transmitted via RS-232 or CAN, or indeed one or the other. So you can select one data set to be transmitted on RS-232 and a second one on CAN. This may be the case, for example, where you're using RS-232 as a source of telemetry data, and you may wish to send other information on CAN to the ADL. So you would use one data set for the telemetry data and the second data set for your ADL data. Now we normally use compound CAN messages to move data around in custom data formats. We're not going to go into a great deal of detail about the difference between the different types of CAN messages. We do have a fairly comprehensive webinar which is entitled What is CAN? And if you wish to have a look at that, you'll see the differences between the different CAN messaging. But we have predefined compound messaging set up in both the ADLs and the M800s to allow reasonably simple setting up of custom data. Okay, so when we've used an M800 with a custom data set, we can actually save this information into what we call a template, and that includes all of the relevant setup data, and you can then import that custom template into an ADL dash, and this is by far the quickest way to achieve a data transfer from an M800 to an ADL or SDL. So we simply use the M800 as a source, and then we set the template into the SDL or ADL as a receiver of that data. And this is a simple process that we will show in the next few steps. That's what we call a template. Okay, so now we're going to look at the actual steps involved in moving M800 data into a dash logger. Once again, we're assuming that we need custom data here and that we can't use a standard data set. So there are 5 steps, each of which is quite important. The last, which is actually very important and should be stressed, because people often set up custom data into their dash loggers or into their M800s, and then they forget to actually log that data that they've added to their configuration. So the 5 steps to get M800 data across to a dash logger are simply, firstly, that you must create a custom data set in your ECU Manager, which is the PC program that operates the 100 series ECU. Save that template, then set the CAN data format in ECU Manager, and then you go across to the Dash Manager software and you import that template into the Dash Manager, and finally you set your logging and display options for the dash logger, and make sure that you send that configuration file to the dash or it won't actually be effective. So now we'll go through each of those steps in turn. So the first thing we need to do to get M800 data into a dash logger is to create our custom data set in the ECU Manager program. So we do this by opening the ECU Manager program, and then we go through our menu structure, which is Adjust, and then we select our General Setup, our Communications, and we click on Set Up Custom Data Sets. And what you will then see on your screen is the box on the left-hand side that I'm showing now. custom data sets. As you can see, there are 2 custom data sets that you may configure. We'll just look at one of them for the moment. Now, what we're looking at here is a custom data set that's already been set up for an application. But if you were to open this in let's say, a blank configuration, you would simply have an empty list there. So what you then need to do is click on the Add button, which is the one I've just highlighted, and that will then open up a second table, which you can see here. Now, this table shows a list of the channels that are available in the M800 or the other 100 series ECU that may be transmitted upon in the custom data set. Now, you'll notice down the bottom here we have checked that little checkbox that says Show Non-Sensor Channels. Now, this is quite important. For example, there are some channels that come into an M800, and here I've shown GPS as one of them. Now, this is not a sensor, for example, like an engine temperature sensor. This is another data stream that comes into the M800, and if you need to transmit your GPS data, you need to have this checkbox ticked, or else you won't be able to see these GPS parameters in your drop-down list. So normally with that unchecked, you'll have a relatively small list, and it will show all of the inputs, for example, for speed, for AV inputs like position, manifold pressure, and also the AT and the switch inputs. So if you need to see the other data, for example GPS, make sure you have clicked on the checkbox at the bottom. And then you'll get quite a long scroll down list. I've just selected GPS quality here. Once you have the channel that you need to add, you click on the OK button, and that will then appear on the list on the left hand side. So it would come down here as number 8 entry, and you can continue to add extra channels until you have the custom data that you need. Okay, so once you've got your custom data, next thing you need to do is export this as a template. So there is a button. In fact, forgive me, I'll just go back to that previous screen, and what we have here is the button which is called Export Comms Template. So that button needs to be clicked. Let's go forward again. So now it will open up this dialog box called Export Comms Template. And this again is a fairly simple process. You simply select which of these custom data sets you need to export. Now you can see here that we only have one of them checked, and that's because we haven't set up our custom set 2 in our configuration. If I had set up a second data set, it would then allow me to export both of these data sets. So that will be checked automatically. Now below here you can see there are 3 different options that you can allow this data set to be exported, and normally we would leave all 3 of these checked, which means you can export this template into any of those devices. Now it's quite handy to put a name in as well, because you will find if you do this many times, you'll end up with quite a large number of custom data sets in your Dash Manager software. So I've just called this one Webinar, and that allows us to see it when we open it up in the program. So when I've given it my name, I click OK, and then I'll see a dialog box like this one on the right, which says that we've successfully exported the template. So then I just click OK on that, and I'm out of the custom data set screen. Now before we can make this active, we also need to set up our CAN transmission screen so that that custom data set has been selected and will be transmitted on the CAN bus. So what we need to do here, again going through our menu structure, we either click using our mouse, or we can just use the escape key and pull down the adjust menu. So we have adjust, then we select general setup, communications, and finally we click on CAN setup, and this will open our CAN setup dialog, which you can see in this box. Now there are a number of what we call CAN slots in the M800, and there are 6 in fact. Normally we would use CAN 0 or CAN 1 as our transmit slot, so I've just set this up in CAN 0. This just allows you some flexibility, but CAN 0 is fine. So the first thing we need to do is in CAN 0 data, we enter in a 4, and that 4 will select custom data set 1, which is the one we've just configured. And you can see here on our help screen on the right hand side, it shows number 4, custom data set 1, CRC32. Okay, so that will be transmitting a data set using that data format on on the CAN bus. And then secondly, we need to set our CAN address, which we've used, in this case, we've used 1520, which will be the address that the data gets transmitted to the ADL on. Now, this address is not fixed in stone. You can choose any address you choose. We tend to use this address as a standard address for ADL transmission, and therefore it would be our suggestion that you follow that address. Now, I do have to point out that in our M800 CAN screen, we are using decimal notation for our numbering. So we've got 1520 as our ADL address. And unfortunately, when we get into our ADL Manager, we're using hexadecimal notation. Again, I'm not going to explain the complexities there other than to refer you back to our What is CAN webinar, where there is an explanation of these two numbering systems. However, if you use the numbers we've suggested here, the two devices will communicate. And thirdly, we need to set our transfer rate. Typically, we may wish to transfer our data at, say, 50 samples a second or 50 hertz. And you have a range of choices here from very low, about 5 hertz, up to about 200 hertz. But for most normal engine data, 50 hertz is a good choice. Okay, now, of course, before we exit from our ECU Manager, we must remember to save the configuration file and also, of course, send it to the M800 ECU. Don't do this again, these changes won't be effective. Okay, now the next step is to open the Dash Manager software so that we can set up how our data is to be used within the Dash logger. So in this case, you're going to be using either the ADL Manager or the Sports Dash Manager, depending on which device you happen to be using. So you open that software, and the first thing you need to do is either open your existing configuration file or create a new one. So in the File menu, you simply use the File Open selection or the File New selection to allow you to have use an existing one or to start a new thing. Okay, so now we open our CAN settings menu. To do this, you click on the menu item connection and follow that with the communications selection. And what you'll see is the screen on the left, which is this box here, which is the communications setup. Okay, so now what we're looking at here is basically a blank one. We've started from a new file, and therefore there are no CAN templates loaded at present. So the first thing we do is we click on this CanOne item, and that will then be blue. And then we click on the select button, which is this button here. Now what this allows us to do is select a communications template from our predefined templates. Now what that does is open this box on the right hand side, select communications template. And in this case there are very many options, so you need to scroll down through this, and at some point you will find, a long way down, you will find these Motec M800 custom sets. And now this is where we'll find template that we've just saved in our ECU Manager. You can see I've highlighted that one. It's called Motec M800 Custom Set 1-Webinar, which is the name that I put into it previously. Now you'll also see how many other custom set ones there are, because I use this quite frequently. So for example, here we've got one for a CDU. This is one of my generic test ones. And we also have custom sets 2, which would have been also created had we set up 2 custom sets in our ECU Manager. So again, we'll just select this one, which is the webinar one, and then you click on the OK button, and that will appear back here on the left where we have our CanOne template set. Okay, so now what you can see is in the CanOne spot, we have our custom set that we've created, and on the right hand side are all of those channels that we created in that custom set in the M800. So in other words, it's imported the name of the custom set and all of the received channels, and that includes how they are configured and what the scaling is. So all you need to do, in this case, you're basically finished and you can click OK. If you need to see the specifics of how each of these messages are transmitted, you can click on the advanced button, which is shown here. I've highlighted it, and that will open up a far more detailed menu item, which allows you to see each of these parameters and what their CAN parameter settings are. However, you don't actually need to do that if you've imported this template. Basically, it's plug and play, if you like. And one thing I'd point out here is that in our M800, we had an item I think, which was a switch item, and what we've now got it as is user 1, because the M800 template doesn't export the actual name of that item, and it comes into the Dash Manager simply as user 1, which was the slot that it was allocated to in the M800. So that's a slight limitation of how this template system works, but it's a fairly minor concern, and it still allows you to rapidly import data. Okay, so we would click on the OK button below that, and that would save this configuration. Now, it's also important when you're in the Dash logger to make sure that you save the configuration as we said, but in addition, you must make sure that you're actually logging this new data that you've brought into the Dash logger, and you may also wish to display it on your Dash screen. This doesn't happen automatically, so you need to select these functions. So you can select functions and then logging, and that will allow you to configure your log channels and add these extra channels. And secondly, functions and display, which will let you display which of these channels is put onto the Dash itself. Once again, you must save this as a file, so we click File, then Save, and you must also send it to the Dash, or it won't be effective. So the final thing is using the online menu, you send online, send configuration. Okay, now that's all it takes to get data from an M800 into a Dash. It's not terribly complicated. These steps, if you follow these steps one at a time, you'll find the process is fairly simple indeed. The converse is somewhat more messy. Getting data from a Dash logger back into an M800 is another thing that has been set up to make it as easy as possible, but a little bit more detail needs to be gone into due to the nature of how the M800 works. It's not possible to create a template in the Dash Manager which can be imported into an M800, so we have to more or less manually set some of this information in the M800. Once again, there are 5 steps in this process. We'll go through each of these in turn. Firstly, we need to create a CAN transmit message in the Dash Manager program. We add the required channels to this message. Then we go into the ECU Manager program, and then we assign these user channels, or we assign these channels as user channels in the ECU Manager program. Part of that process is to set the calibration and so forth, and finally set the logging options in ECU Manager and save the configuration and send it to the ECU. Okay, so we'll go through these step by step as well. Again, this is a slightly more complex process. If you don't need to do this, you can easily skip this part of the webinar. Alright, so the first thing we need to do, again, we're looking at getting data from the Dash logger back to an M800. So we need to create a CAN message in the Dash Manager, which is going to transmit this message back to the M800. So once again, we open our file, or we use an existing file or create a new file. Once again, on this screen, you can see a blank communications setup. This is in fact the same screen as we just showed before. However, we're going to use this screen differently. In this case, we click on CanOne. Again, we're going to use CanOne as our transmit message rather than our receive. Any of these CAN slots can be used. And then we click on the advanced button, which is this one here. Okay, now what that's going to do is open a different menu to the one we saw previously. So let's have a look at that. So now we're looking at a COM setup for the CanOne message. Now, initially this message would be set up as a receive message. So we need to go through each of these steps to turn it into a transmit message. Firstly, I'll just go through these steps one at a time. We click here on this drop-down bar, and we set transmit message as our device parameter. Secondly, the fixed binary we don't need to change. The alignment we don't need to change. The receive timeout, in fact, is irrelevant because we've now created a transmit message. Now, what is important is that our base address is set correctly. And again, I would remind you that the M800 uses hexadecimal notation for its channel naming, whereas the Dash Managers use hexadecimal notation. So the matching hexadecimal number for our previously set ECU Manager number is 5FA. If you enter this number, then the two devices will communicate. You can see here we have the option of setting a CAN bus. Now, this depends on which Dash device you're using. Our earlier Dash devices only have one CAN bus, but our SDL3 and ADL3 have two CAN buses. and of course these can be run at different speeds and with different devices attached, so it's important to make sure you do select the correct CAN bus. Okay, now again here we've selected our transmit rate at 50 Hertz. This is a fairly common speed for general engine data. You may wish to go as low as 20 Hertz for less critical data, but we would normally suggest 50 Hertz. So that's set up our CanOne message as a transmit message at the correct address and at a reasonable rate. Now there's a second tab on the top of that screen. We were looking at the parameters tab, and now you click on the transmitted channels, and this is where we need to set up our detailed transmission information. So the first thing we need to do is tell the Dash Manager that what we're looking at is a compound message. So we're going to click in this message type. We're going to set that to compound. I won't go again into great detail about this, but just follow these steps and you'll find that the right things happen. Now you can add up to 12 transmit channels into this message if you use a compound message, and so that's normally, again, that's the way we do it, and subsequently we'll also be setting the M800 to work in the same fashion. So we set that to compound message, and then we click here on this first identifier number, or we click on that there, and we get a blue bar, and then we click the change button, which is this one down here, and that allows us to enter in the values which you can see in this message here. Okay, so when we click on the change, what we need to do is enter in the following numbers. Firstly, in the offset, we leave that at 0. Secondly, our identifier, we need to set an ID number, which will be 0000 for our first message, 0100 for our second message, 0200 for our third message. So again, we have the choice of sending up to 12 messages, and that means we could up to 12 channels, which means we can put three channels into each of these identifiers. So without wishing to get into great detail, you simply, if you only have 3 messages to send, you only need to use one of these identifiers, which is the first one. Our identifier mask is set to FF00. Okay, so once we've set our identifier, we can go across and click on this add button here, and that allows us to select which channels in the dash are going to be transmitted in this first message. So we click on our add button, and then what we have is this box which is called add comms channel, and the channel designation is actually blank. Now you cannot type into this box. You have to click on this select button on the right hand side, and it will show you a very long list of the available channels, and you can use numerous different tabs in this search mechanism to find the channel that you're after. Now the simplest way we find is to click on the unused tab, and what that does is show you which of your dash channels are available that haven't already been selected for transmission. Okay, so we click on select. Now for our first message we need to have an offset of 2, which is there. Our length is 2, and then the multiplier, divisor and adder are normally defaulted to 1, 1 and 0, so we don't need to change that. For this messaging to work correctly, however, you must have a length of 2, and your offset will be 2 for the first channel that you add. It will be 4 for the second channel that you add, and it will be 6 for the third channel that you add. If you have more than 3 channels, we'll explain later how to add those again, but essentially you need to make sure that this offset is correct. Then you click on the OK button, and you will see that channel is then displayed in your list. So I'll just show you now. I've added four channels to this transmit message: engine revs, engine temp, user 1 and throttle position driver. And so what this is effectively doing is actually taking up 2 of these identifiers. If I just go backwards slightly, 2 screens. So the first of my identifiers, which is identifier 0000, as we see here, that would include those first 3 messages, and then I would have to add a second identifier here, which would be 0100, and that would add extra channels after that. Okay, I'm just going to go forward back to our other screen. Alright, so now what we can see is that we have, I've given a name to this as well. It's quite handy to give a name. And then we have our 4 channels. And once again, we must save this file and also send it to the dash. So firstly, we click File and Save, and then we click on Online in our menu bar and send our configuration to the dash. If this doesn't happen, then the dash won't be transmitting the data. Okay, so that's all we need to do in our Dash Manager program. Now, to accept this data into our M800, we go into our ECU Manager program and we open the configuration file that we're using in this case, and then we use the menu structure to go Adjust, and then the General Setup, Communications, and back to our CAN setup. Okay, now again, this is more or less the converse situation to the one we've just shown. In this case, I've decided to use CAN 2. Now these CAN slots, CANs 2, 3, 4, and 5, and 6, are more than likely to be used as a received data type situation. And so you can see here, I've entered number 4, and that there correlates to this this type of data, which is ADL receive, which means it will understand the type of message structure that it's going to get from the ADL. And secondly, we have to enter our CAN address. Okay. Now, 1530 is the decimal equivalent of the 5FA we had in our Dash Manager transmit message address. So again, these two numbers, although they're in different notation forms, they are actually the same number, and they must match or else our data won't be received. Okay, now we go to, we have to actually assign each of these channels as an input into the ECU. And the only way we can do this is via our input menu, even though these aren't actually input pins. Clearly they're a message rather than an actual physical input pin. So we go in our ECU Manager program, we click Adjust, Sensor Setup, Input Setup, and that will open up your input pin setup screen, which you can see down below. It's actually, at the moment, it's actually covered by another screen. That's our input pin setup screen. And then I've clicked on the engine temp channel, which is one of the ones I'm bringing across on the CAN bus. So I've double clicked here, and then that opens up our input setup for that particular channel. So you can see here it's called engine temp. And now what I've done is I've clicked down on this little pull down button here, and I've selected ADL2 as the message that I'm going to use for my input pin. Again, it's not actually a pin, it's a channel. Okay, so ADL2, now that means it's the second message that's coming from the second channel that's coming from the ADL. Now below that, you can also see some calibration information. Now this is also important. We'll explain this a little bit later, but normally, of course, if you have for example, a temperature sensor going into an input pin, what it produces is a range of voltages, and then the ECU Manager has a predefined table which matches that particular sensor. However, what we're receiving is actually CAN data, and so it comes in just as simply as a number on the CAN bus, and then we have to assign how that number is translated, you might say. So what I've got here, it's set to 1:1, and then it's also got degrees 1 decimal place. And that's because I'm bringing it in as a temperature, and in my Dash Manager, in fact, I neglected to show you, but we can go back and have a quick look at that. I'll do that right now, as a matter of fact. If we just go back to our Dash Manager setting, one thing I forgot to mention, unfortunately, this is adding the channel. In this case, it's engine revs, but it could have been the engine temperature. Now, what we have right here is the base resolution, and you can see there that says 0.1 hertz. Now, the other way to term this is to say it has 1 decimal place. So it's a number where it has a resolution of 1/10 of a hertz, and therefore it has 1 decimal place. So I'll just skip forward again to our other screen. I apologize for this. Okay, so now what we're looking at is the similar thing here in an M800 ECU Manager. We have degrees C and we have 1 decimal place. I'll show you this just in a slightly more detail in a moment. Okay, so that means we've selected our input source as the second channel coming in from the ADL, and we've set our calibration as 1:1 with 1 decimal place. Okay, so the way these channels come across from the ADL, just to remind you, is we have a number of IDs, and we have a number of channel offsets, and these are the things that we set up in the transmit message in the ADL. And then this is what it is termed in the M800 as an input source. So again, I was using the example of the second transmitted channel, which is called engine temperature, and it had an ID of 0, an offset of 4. That's the way it's set up in the ADL. But when it comes into the M800, it's simply called ADL number 2. And again, if we had up to 12 channels, we would have created each of these channels and messages using the identifier and the offset, as we described previously. And this would give us up to 12 channels into the ECU. And just another quick look at how this channel scaling works. What we have again is that CAN is simply a message format where the number is transmitted effectively without any decimal place information. It's just a simple number, or as what we call an integer. And then in the ECU and in the dash manager, it defines how many decimal points are relevant for that particular channel. Okay, so for example, the dash may be transmitting a number like 1234, 1234. And this would be typically used, for example, for engine RPM. Now, in the case of engine RPM, we may have 0 decimal places, and that means that a value of 1234 is actually equivalent to 1234. If we transmitted that using 1 decimal place, the actual number transmitted is the same, which is 1234. However, the ECU will interpret that differently, and it will add a decimal place there, as you can see. And in this case, therefore, that number is translated as 123. And this is very typically used for things like speed channels. Again, you can see here, if we use 2 decimal places, that number 1234 then translates as 12.34. This is another common setting that we use for things like voltages, where we need reasonably good resolution. And finally, you may see 3 decimal places values, and again, 1234 in this case would be something like lambda of 1.234. So the point we're making here is that if we don't set the number of decimal places, we can end up with our readings being out by a scale of 10 or 100 or even 1,000, depending on how the data was transmitted. Just another simple example of a much smaller number there. If we're transmitting a 15 as a raw number from the dashboard, that could translate as 15 if there were 0 decimal places, and it could be a tenth of that, 1/100th of that, or even 1/1000th of that if we had 3 decimal places. So again, this is something where we need to define that in the way it gets received into the ECU, and of course the idea is that both of these decimal place figures are matching. So you should note this down in your settings in the dash manager, and then when you go into the ECU manager, you can select the right number of decimal places. Okay, the final thing you need to do in the ECU manager is the same as you would in the dash manager, which is firstly you must set which of these channels you've added you'd like to log. It's a little bit pointless to have them if they're not logged. Of course, they can be used for engine control as well, but it's worth remembering to set the logging up as well. And finally, you would save the configuration file and make sure you send it to the ECU. Now, our habit is normally to give the configuration file a new name or a sequential name or a slightly different name, just so that we know what's been added and why it's there. Okay, so that's finally all you need to do. Now, clearly sending data from a dash to an M800 is a little bit more complex than sending data from an M800 to a dash, but both of these systems work quite well. And if you find that you have trouble, it may be worth just going through each of these steps again and replicating the settings that we have used to see if you can get the same things, get the behavior to operate in the same fashion. Okay, that'll be the end of this webinar. Thank you very much for attending. Now we have a number of webinars that have been recorded previously, as is this one, and that means you can access these on our website just simply by going to that first website address that you can see there. And this will give you the ability to play back any of the webinars that we have recorded. And secondly, we also have Motec forums, which cover many of the topics that you've seen today. And we have forums for each of our major product ranges and also for specific applications such as PWCs. So both of these are avenues where you can gain more knowledge, and you can also interact with other Motec users, especially on our forums, and you can have discussions and see what other people have done in terms of solutions as well. Thank you very much for attending. That'll be the end of this webinar.